Good day everyone, I am here to present to you a short introduction to steganography. Steganography was first introduced during the time of Greeks by a historian named Herodotus, who has been called the father of history. There have been different forms of steganography for the past centuries. The Greeks used it by inscribing their hidden messages into a tablet and covered it with wax to conceal their messages. During the Second World War, the Germans used microdots, wherein the size of the text is reduced to a point where it already looks like a dot. As of now, there are already numerous types of steganography, and one of those is digital steganography. So what is steganography? Steganography is a technique used to create hidden messages within another data. It has been a way for the sender to communicate with the intention of having a specific piece of information that will only be available to a specified receiver to avoid others from finding out. It may be through audio, file, text, videos, images, or etc. It includes two texts, which are the ciphertext and plaintext. So what is the difference of steganography and cryptography? Steganography is when you hide your message in a certain data. For others, this may seem like a normal text or a normal image, since they do not know that there is something hidden in it. While cryptography is when the message is incomprehensible to those who do not know how to decipher it. These are the types of steganography. First is technical steganography. An example of this is when we use invisible ink to hide our message. Second is linguistic steganography, which can also be classified into two types. The first is the open codes, which consists of jargon code and covered ciphers. Covered ciphers can also be classified into null cipher or Grail cipher. The next one is semagrams, which can be divided to visual semagrams and text semagrams. For our topic today, we will focus on images, which is classified under visual semagrams since it may appear as a normal object but actually has a secret code in it. Like this, for example, the image on the left actually contains a hidden message which can be seen on the second image. This can be decrypted if you know the password set by the one who made the image with the secret message. So how does this work? How is it possible? Well, this can be done through different images encryption methods, which is the mathematical explanation behind steganography. First is the least significant bit technique, or the LSB technique, which operates on the principle that the human eye cannot distinguish between two shades separated by only one bit. It is composed of two matrices, which is the C data, that is composed of unsigned 8-bit integers, and a color map. We have to strip the LSB from the C data, then replace the LSB in each pixel with 1 bit from our message. So, to encode algorithm using the LSB technique, first is we must turn message character vector into doubles. Second is we use T2 to create a matrix of binary digits. Third is the first element, which is 1, 1, of the cover image C data vector is set to n times 7. Fourth is we subtract an integer from 1 to 8 from the second element to indicate which bit is used. Fifth is we strip the chosen bit from other pixels using mod LX. Lastly, we add each element of the binary vector to an element in the cover image. So now, we can decode algorithm using the LSB technique by first, read the first two elements to determine the length of the message and which bit to decode. Second is, use the mod LX function to strip a particular bit, then divide these values by the value of that bit to get binary digits. Third is we use that to populate a matrix in which null matrix is equal to encoded image 1, 1. Lastly, use by2DE to convert to a vector of doubles, then cast as characters. Next is the RSA technique. The RSA technique is also used in cryptography. As you can see here, for red, green, and blue, they all end with 1. But when we apply the RSA technique, we can change all of it to 0. So located at the left side of the slide, you can see the different equations that we will use when we will solve using the RSA technique. Let M be equals to plain text and C be equals to ciphertext. So, let M be the ASCII code of the plain text and C the ASCII code of the ciphertext. So first, we must choose two large prime numbers, let's say P and Q, which must be between the range of 1 to 100. And then we have to compute for phi n, which is equals to P minus 1 multiplied to Q minus 1. Next is we have to compute for n, which is equals to P times Q. Then choose any number that is a coprime to the value that you got from solving the phi n. Compute the value of d following the equation that d times e is equals to mod phi n. Then, we will get the public key and the private key. After that, plug the values for the encryption and solve for M. Then, solve also for the decryption to check if it is correct. Let us now have an example. Let us say that P is equals to 59 and Q is equals to 89, which are both prime numbers. Then we choose 3 as the value of our E. Our plain text is 01010110. We have to solve for a ciphertext. So first, we must solve for phi n, which is equals to 59 minus 1 multiplied to 89 minus 1. We will receive 58 times 88, which is equivalent to 5,104. After that, we solve for the n, which is P times Q. So, in plugging the values, 59 times 89, wherein we will get 5,251. The next step after that is that we have to choose any number that is coprime to our phi n, which is 5,104, and 89 is the number that we pick since they are both coprime. Then now, we have to compute for d using the equation d equals 1 divided by e times mod phi n. Putting the values, we now have d equals 1 over 3 mod 5,104. Solving for 3 mod 5,104 will get us 1, and 1 divided by 1 is also equals to 1. So now, we have the value of our d. Now that we have the value for our d, we can now have our public key and our private key. Now let's say the value of our m is 39. So using the equation for the encryption, which is c is equals to m raised to e mod n, we will now input the values. So c is equals to m, which is 39, raised to our e, which is 3, times mod n, and n is equals to 5,251. Now, we have all the data we need to find out the secret message from the example given to us. This is where the discussion ends, and thank you for listening. I hope that you learned something. Thank you!